Okay, first of all, let me let's talk about the hackathon for a few minutes. So, April 14th from 8 a.m. to 8 p.m. It is a Saturday again. I do require it for all my classes. If for some reason you're able to make it, I have an alternative assignment. Um, so you have over a month to ask for time off of work or something like that. Email Josh Locklear. CC me on it if you would, because I'll be putting together the teams. Let him know your preference, whether you want to be on a team that's doing something in either virtual reality or augmented reality or something with mobile applications. And we'll divide up teams. We're going to kind of have a central theme, and then you'll be making apps related to that theme in either one of those platforms, depending on what you're more interested in. What I've been pushing people to do, I know some people really like the VR stuff from last time. Some people didn't really like it. I'm Let me give you some examples. So right now, coming out of computer science, the highest paying jobs you can get in CS right now are mobile. Tons and tons of job for iPhone, Android applications, that kind of stuff. But you're starting to see everybody has some jobs for virtual reality and augmented reality. In 2-3 years, all the jobs are going to be VR and AR. That's where everything is going. They're going to come up with ways of doing that stuff. This past summer, I had two of our former MSIT students working with me on a virtual reality game. Both of them ended up getting $100,000 jobs. Well, I guess one of them got a $75,000 one. The other one got a $95,000 one, doing virtual reality stuff. So, and these are Indian guys that are hard to employ in the United States right now, and they found jobs in VR. So having a background, having some expertise in writing software using game engines for VR and AR, I think is going to be a big deal. So if you're looking for a skill set that makes you more marketable moving forward, I think that's the one. Mobile apps makes you marketable right now, but I think VR also makes you very marketable right now because places are looking for people who can do VR, and there's not that many people who are doing it. There's tons of people who are doing mobile applications. So my recommendation would be to suggest VR unless you just hate it. Or you just have a real great reason where you want to do something with a mobile app. But we have them both as options. That way you hopefully get the best educational experiences you can get out of the event. Questions about the hackathon? Breakfast, lunch, dinner, all provided. Something like that. It's a good educational opportunity. So if you perceive that you suck at programming, it's not a big deal. I'll put you on a team that has some stronger developers on it so that you get something out of the event.
How many students showed up to the last one? Was it a good amount?
Oh, yeah. But we do spread out across multiple rooms. So, and now we have some more mobile workstations. So we have 3 mixed reality helmets with laptops to drive each of those. So we don't have to bring sensors everywhere now. So I would say last time we had maybe 6 teams of 5 or something. So like 30 people, something like that. Ballparky. Yeah, but, and then we have them spread throughout the department. So we'll do probably the same thing. Okay. Any other questions about Hackathon? Also, another reminder, so both of the flyers are up there. So the Hackathon's back there on the door. And then also it's the, March 22nd is the computer science get-together. So that's down the hall. It's from, 11:30 to 1 or 11:30 to 12:45, something like that. Go to that. Comes with free lunch. And that's also the thing where if you show up early and you do that little meet and greet thingy where, find somebody who wears the same size shoes as you, that kind of stuff, you get first dibs at the good prizes. I mean, prizes historically have been like iPads or, nice monitors or nice printers and hard drives, solid state drives. I think this time there might be a PlayStation 4 VR setup. I think that's one of the prizes. So good stuff. Make sure you show up to that if at all possible. Even if you don't win the little meet and greet thing, be one of the early people to get the quiz questions right, and you will get one of the better prizes as well. Otherwise, you're down the list and dealing with Chuck Norris stuff. Um, so we've run into some compatibility issues with some of those Chuck Norris prizes where they no longer make the devices that play them. But don't let Dr. Locklear know that VHS is no longer a thing. So,
Well, then there should be a VHS DVD converter.
or a VHS player comes with the DVDs. It comes with the Chuck Norris VHS tapes come with a VCR.
They like make players now that will do Blu-ray and VCR, which is just ridiculous. Yeah, they're like $80.
Yeah, but so is there like is it a comeback thing? Kind of like, aren't like record stores going to start, or music stores going to start selling vinyl again? Like that's like a new thing,
vinyl
right?
Vinyl is coming back, but VHS, I know that like the value of VHSs is like skyrocketed. If you have like collectible VHSs of just like classic Disney movies, I know for example, you can get like $1,000 on like
you
the
serious?
original VHS. Yeah.
Oh my gosh.
I know like people that hang on to like their VHS tapes from when they were like kids because it was like that's how they watched it then, and like it's special to them, like sentimental.
Too.
Not necessarily.
Yeah, well, I'm not. Yeah, I'm not even talking about that. We're talking about like street value. What's the street value of a Sesame Street VHS tape?
People that don't have their VHS tapes from when they were kids either, and they like wanted the way that they watched it when they were a kid. Even I know it's weird.
Couldn't even imagine. We had 8 tracks, so before cassette tapes, you had 8 tracks.
Yeah, I don't think that's coming back.
Yeah.
Maybe.
Remember my Fisher Price record player? my brother and I, we 1985 Chicago Bears had the song the Super Bowl Shuffle, and you can still find it on YouTube probably, where they sang the Super Bowl Shuffle thing. And so my brother and I, we like made like, we dubbed copies of this. We were selling it around town. They were horrible quality. I think the first one, my brother, we had some parts missing, so he was like just singing in the lyrics.
People paid for that? I'm sure they didn't know what they were buying.
Well, this is coming from, I think I've told, this class I told about the leeches. In high school, there was a biology class, and they don't do this anymore, I mean, I would assume. But, you know, there's this big list of like 50 things that you had to go out and like find these things. So you had to find like, you know, find a snake and, you know, a crawfish, you know, bring in a leech. Yeah.
What?
Yeah. So then the teacher would sign off on your sheet that you brought this thing in. So my brother, I didn't do this. My brother did this, but it was a good idea. He decided leeches might be hard to find. So he found a source. So then he started selling leeches at the school. He's selling leeches out of his locker. People going up saying, "You got this stuff." It's like this deal's going down. Selling, you got suspended for 2 days for selling leeches. That's opportunistic.
We did that. Like we did like this thing called Uproar, where it was like a bunch of like our Lutheran grade schools like got together and we like went on something like and we did that except we did it with like water and sex, so it wasn't as exciting.
Yeah.
Like go to the lake and find the water.
Well, those things bite.
Well, I mean, that's the thing. You're telling these high school kids to go out and find a snake. You don't know if that snake's poisonous or not. So my best friend and I, we're underneath this bridge down by the golf course, and we see this snake. Oh, I mean, that thing was ticked off, and we're here like messing with it with sticks. We don't know what we're doing. We caught that thing.
You know what kind of snake it
I have no idea. We brought this snake in a garbage bag. So I'm carrying a live snake that's like hissing and stuff inside this bag to class. That doesn't happen anymore. We don't, that's not the way it works. I don't even think that's the worst stuff that was on that list. There were some other things. I don't even remember now.
It's so harmful for the environment.
Yeah, he didn't do it that year. He might have got fired that year, that teacher.
Good.
I don't know. I mean, he wasn't encouraging us to go and kill the animals.
Well, yeah, but you're taking the poor animal. He's probably like really stressed out from being moved.
Probably.
Black bat.
I mean, we tormented the snake with those sticks. We
Yeah.
didn't know what we were doing.
Probably killed him from just being stressed.
Quite possibly. This is the same teacher. He had 2 giant pythons in class. Like he had like a terrarium thing set up.
What kind of pythons?
I don't know.
What color were they?
They were green.
Oh,
I'm guessing, was that a normal python, not a Burmese or?
yellow.
Yeah. But he would every Thanksgiving, they were big. These were big. He would feed it a turkey.
That's like.
He would put a turkey in there, and make us. Well, not make us. We all wanted. All the boys wanted to watch this thing eat the turkey.
It wasn't a live turkey.
Oh yeah.
It was a live turkey.
Yeah, his turkey's running around trying to get away from these 2 giant snakes.
Oh my gosh.
This is how school used to be. This is back when they still used to hit kids.
Wait, the teachers did the kids.
Oh yeah.
What?
First
What
grade.
is this?
First grade, I got hit 3 times.
What a teacher.
And oh yeah, I even remember you come out of the room, you turn right, you go about maybe 50 feet down the hall, you make a little left into this little broom closet. In the broom closet, there's a single light bulb. You pull down, and she has the instrument of death on the wall. She pulls it down, just beats the crap out of you with it.
What are you
She was
talking
so
about?
happy.
What the heck is what year is this?
Well, a couple minutes ago. It's like in the early 80s.
No way. No, I need to ask my parents about this.
Oh yeah, and then so after you get spanked in school, then they call your parents in afterwards. So after school, so that the teacher could stand there and yell at you in front of your parents. Okay. And my mom's like giving the teacher like a high five. Oh, they're thrilled. Like, oh, somebody needs to keep him in line.
Did you say it was like eating crayons?
And one of the times I ate a crayon. Another time there was this girl in class, and we exchanged papers to grade their spelling tests, and I wanted to mark her test wrong, so I changed cat, like she spelled cat. I changed the C, but I had horrible handwriting, and she had like perfect handwriting. It was like very clear that test had been modified. But I thought nobody would notice. So I don't even remember what the last time she might have just done it because she wanted to. There was another guy in class, Steve Scott, and I remember what he was doing, but when he got out of line, there was one time, and she said to, I remember, this is quote, "Steve, I've been waiting to do this for a long time." Years and years later, she went to the same chiropractor I went to when I was not a first grader anymore. So, but chances are I probably needed to be hit. I'm just being honest. I mean, you can only eat so many crayons before it makes you sick. Somebody's got to put you in line.
I had no idea.
Oh yeah,
Teachers can hit their students. That's crazy.
That was
That blew my mind.
good old days.
They're good old.
Yeah, see now we have to use all sorts of like alternative things. Like I have to assign a student in the class to like put a hit on another student, and I just have to look the other way. Yeah, so technically I didn't do it. What's this?
Are we part of the mafia now?
So I don't know what you're talking about.
Part of the mafia.
Yeah, so those were the good old days, I suppose. We had another guy in high school who I don't know if he was a vampire or at least thought he was a vampire. He got arrested someday because he had gallons of blood in his locker. I think it was animal blood. But he was never going to the cafeteria for lunch because he was going back to his locker to feed.
No.
Oh, so good. Okay. So let's spend a few minutes. I'm not going to give you any homework, obviously, but let's spend a few minutes talking about interprocess communication, really talking about processes in general. So we've been talking about process control blocks, so these PCB guys. And we know how to create multiple PCBs. All right, create multiple PCBs. And so you might have an application. So for instance, in our little web server thing, we created multiple PCBs, one PCB per incoming connection, right? And had that process handle that person's incoming connection. And the number of simultaneous connections that we can handle is really going to be based on kind of the machine that this is running on, how much RAM it has, how many processors it has, and things like that, because you got to consider if you're on a single core machine, so it's called an older machine, only one thing can be happening at once. So even though you've created 30 processes to manage your 30 incoming connections, only one of those guys is actually going to be getting CPU time at any point in time. But the idea is that CPUs are fast enough, and since you're doing mostly I/O, that they're not going to have to spend a lot of time on the CPU. So everybody feels like they're getting real-time service. But obviously, a weaker machine like that is going to get overburdened quicker than a stronger machine that has, 12 processor cores and, a bunch of RAM and a whole bunch of stuff like that. All right, so if you want, and then you go even farther, you look at something like Google's web server. It's not just a single machine. Now they have a warehouse of machines that are all load balancing. So when an incoming connection comes in, they send it to a computer, the next computer in line that's the least busy right now, or something like that. So each person becomes one, probably a thread. But right now we can think of processes and threads as equivalents from our perspective. So it effectively is a mechanism to avoid blocking, right? So when before when we had our server, if we had one client connected to the server and we didn't fork a child process, then what we would have is we'd have the first process blocking that next incoming connection. So we could not accept yet because we actually hadn't come back and waited by the phone. Now we're spawning off a child process, and we can handle that. So as you get into larger and larger applications that require more and more incoming connections, let's say, or simultaneously connected users, like in a MMO video game that has a whole bunch of people in it, then you need to have a machine that can support that. So if in the gaming world, whether if you're playing Counter-Strike or World of Warcraft or something like that, depending on how their multiplayer is kind of set up, usually servers, you might go into a game, you have to pick a server, right? There's 30 servers to pick from, depending on how popular the game is. But you pick a server, and a lot of times when you first start your character in a game, they suggest a server with low population. Kind of seen that before if you're starting a game, because they're putting you on a server that doesn't already have a lot of other players in it. Because what they're trying to do is they're trying to manage the maximum number of players that are on at any single point in time. Now, after a game like that has become very, very popular, then all of a sudden you have maybe many servers that are all overloaded, right? So then sometimes you log in and you're in a queue. So maybe they have a cap set up on the server where, let's say 500 people can be logged in at once. Just picking a number out of the sky. So if there's already 500 people online, you have to wait for somebody to leave. Kind of like going into a restaurant, there's, all the tables are taken. All right, and the reason they're choosing that is because any more people on the server than that is going to then overload that server or start having performance issues, which then degrades the quality of the game or something like that. So these are all things we have to consider. We can't just haphazardly create more and more processes and just think that everything's going to be okay, because at the end of the day, we're still sharing the resources of the underlying system, okay, the underlying computer. Okay, so how many of you have heard of something called a multi-user dungeon? Okay. So obviously in here, we are focused more on the programming, the systems aspect of this rather than graphics and things like that. So what we're going to do is we're going to be looking at examples of network programming through a video game, okay? But not a fancy schmancy video game with all sorts of cool graphics and stuff. We're going to be looking at a video game back from the days when teachers used to be able to hit the students. So this, that's actually too high tech. This is what it maybe looked like. Can I get a big?
So kind of like in a sense of like cave crawler.
Cave crawler, something along those lines, but a network aware one. Yep. Yeah, so something like this, where our if you want to hit the third button down, please. Thank you. All right, so something along the lines of this. So you connect in, and we've actually seen something pretty similar to this, right? You know, with our web server. So we're telnetting into something. So here's telnet to some IP address. We'll probably provide a port. It's going to finally connect. You know, then you go through the character creation or something like this. So this is more of a Dungeons and Dragony type thing. You know, so if you go full bore on this, then you're picking your race and then your class, and then you're rolling stats for intelligence and all this stuff. So you know, these MUDs were big deals. And you know, at the beginning of class today, was it Alexis that asked me how long I spend? Oh, it was you that asked me how long I spend in VR each day. I try to play games in VR where I have to stand, because then that limits the amount of time I can play. So that way it's sort of a workout. So my limit's around an hour. So before I get winded and or my leg starts hurting or something like that. But these, I mean, I used to play probably these MUDs, I don't know, 10 hours a day for a while. I mean, this was World of Warcraft before you had World of Warcraft. Or this was, EverQuest was kind of the first real, you know, cool version of something like this. But, you know, it was all text-based, where you had a list of commands that you could, you know, so you could talk to other people that were in the same room as you. So you would, you know, send a message. You can look around and see the room you were in. So even if we think about this just from a chat room perspective, okay, so we kind of start off, you know, we ultimately want to build something larger, but even just from a chat room, if we want to have a kind of a shared experience where multiple people can connect in and to a same central server and sit there and talk to each other, either send private messages or have kind of the global general type thing. What does it take to accomplish that type of thing? So if we just kind of think about that at the chat room level here, we will have a server. So we'll call this guy the chat server. Okay, and this guy's going to use our sockets to, you know, listen and accept, very similar to our web server, right? And when a connection comes in, instead of speaking the HTTP protocol, so if we have these two guys, so we'll call this a client. This is a chat client. This is a chat client. And both of these guys connect into this chat server. The chat server then creates a child to deal with each of these chat clients, right? And the server can know about who their children are, so the server can start creating a collection of all the process IDs of the children. But ultimately, when, you know, let's say this is me, and I'm chatting with Annie, and I want to send a message. I need to ultimately get a message from my terminal to Annie. So I'm going to send the message, hi, but now we got to decide, how does that get there? Right? How do we actually get information? So I'm sitting, you know, if we want to just stretch the imagination, I'm in Moscow, okay? She's in Chicago. Okay? Different parts, we're both connected in over the internet to some central server. All right, so we connected here, the server spawned off a child, so she has a link between her and her server helper, we can say, something along those lines. Well, this dude has a link between him and his server helper. So now when I want to send a message to Annie, we have to think, how does this get sent? I'm not sending directly here. At least I might not be sending directly here. If we wrote a chat client rather than just using Telnet, we potentially could write into the chat client its own server. All right, so if we think about how does BitTorrent work. So BitTorrent is a peer-to-peer type network, right? Where each individual client in BitTorrent is a server. So when you're connecting, when you're grabbing these 16 bits from a certain client, you're actually connecting to their IP address and grabbing 16 bits from here. Then I'm connecting to this IP address. I'm grabbing 16 bits from there. And so you're collecting, almost think about you have this file you're trying to put together. And you think of it like a giant puzzle. All right, so you're looking for all the pieces. This could be, you almost can think of it like collecting baseball cards, and you want to get the whole set, everybody on the team. Okay, and let's say this person has these 3 cards. So you say, okay, I'll get the 3 cards from you. This person has 2 other cards that you need. You grab 2 from there. You're looking for peers that have the cards that you need. That makes sense? So that's why the more peers, the more people you have on network sharing the data, the more opportunities you have for getting the cards you're looking for. But each of those clients in that example are servers as well as clients. So in that example, I would connect directly to Annie's client server, which requires a piece of software. So like if you're on your computer, you download MuTorrent or something like that, some torrent software, because you need specialized software in order to participate on the BitTorrent network, right? Because your machine is doing more than just downloading. Your machine is also uploading. You're a client for somebody else's server. You're also the server for somebody else's client. It's doing both of those things. Well, in our case, if we want to have our chat client work completely over Telnet, where we don't have control over the client-side application. That's just a normal Telnet terminal. We're not, the person's just typing at the terminal. We don't have the ability to listen for incoming connections and stuff like that unless we provide them with a chat client that works proprietarily with our chat server. So if we're just writing this generically, I can't send a message directly to Annie. Well, why not? I don't know about Annie. All I know is how to talk to the child that was, provided to me. So maybe this child, so let's say I type look or something like that. I want to see the list of all the people that are currently in the chat room. So I might send look to this child and say, let me know who else is in the chat room. Well, keep in mind that this server is sitting here still waiting for more incoming connections, right? So this guy's sitting here waiting for somebody else to connect so it can spawn off another child. Okay, so he's waiting for an incoming connection. These are the couple of children he's already spawned off. Maybe this guy, every single time a new connection comes in, he's creating a list of those connections. And those connections are being maintained by our child PCBs. So if I were to ask to show me all the people that are in this room, just a list of names, let's say, we have to think, how does this process, because these are 3 separate processes, right? This is the original chat server. This is a duplicate of it, and here's another duplicate of it. But these guys are running logic out of an if-else, because they're deciding, oh, I'm the clone, so I do child stuff instead of go loop back around and listen again. All right, so these guys are going to be a duplicate of the chat server, but running other logic. So now we have to say, well, how does this guy find out about who else is connected? How does this guy find out about this guy? We're going to have some mechanism here in the middle for this process to talk to this process, or for this process to talk to this process, something like this. Okay? If we want to think about it in terms of applications that we've written before, we almost need something along the lines of a singleton. Where there's kind of this global repository of information, who's currently connected, stuff like that, that any one of these guys has access to. Okay? Now that's pretty easy when you're writing a standalone computer program where all your instances of objects are all in the same place. Okay? That's not necessarily the case here because we're not controlling our environment. Because what surrounds all of this? Surrounding all of this is, we should change the color of this guy. This is our OS. And then can't I arrange this? Arrange back. Look at that, Keynote Pro. I like drawing pictures on there, it's so fun. Hence the crayon eating issue. I tried to take care of that early. Yeah, that is one thing that has changed though, and now you have kids with like video game addiction and stuff, where they don't get out of the house. Where like when before that was like a thing, I mean, kids were just breaking arms and stuff left and right. I mean, one time I watched my brother; he must have fallen 60 feet out of a tree. We were playing laser tag, like when laser tag was like cool and like it was like something that was kind of equivalent to VR. Like it was like the cool techno thing. He got shot so many times falling down this tree. He fell 60 feet, hit every single branch on the way down. Thumped on the, by all measures, he should have been dead. Got up, turned the thing off because he was beeping because he got hit. And they said, "You missed me." And I mean, the number of times him or I actually almost died. My dad was a dentist. I remember one time the neighbors they called over to the office because he said your boys are on the roof or something like that. Boys are terrible. They're just terrible. Okay. So in any case, we have this operating system here, and this guy is where all these pieces live. Let's go ahead and dump the Singleton for right now because we need something like a Singleton. We kind of need a replacement for it. So all these processes are living inside the operating system. Okay? So we want to know what kind of facilities does this operating system provide to us that allows us to allow these three guys to talk to each other. Different things like that. Okay? Now one of the things we might want to do is we want to have something called shared memory. All right? So we talk about the types of inter-process communication. We have something called shared memory. Now, at the high level for us, at least right now, we can really think about this as kind of like a Singleton, where you have this one piece of memory that all those processes get to share. All right? So, again, at the high level, we have 3 minutes left, kind of diving towards midterm or diving towards break, and I'll talk about the midterm here in a second. You have this idea of some shared memory that might live in the middle here. And this shared memory is initially created on the server, but you create it in such a way that all of the children, they get copies of that variable. Okay, so we saw this before that, when we fork and we get a new process, all of the children get their own copies of all the variables that previously existed. They all have the same integers, they all have all that stuff, but they have their own copy of it. Even memory, they get their own copy of memory. So if you had an array, they would get a brand new array, but it would have a different address. So you wouldn't be able to do the whole pointer sharing thing, like, oh, I'm going to write in the same place. That's kind of what shared memory lets us do. It allows that pointer to persist. So we are able to then create a variable at the chat server level so that children who automatically get that same variable have the same variable, not a copy of it. So they can use that for communicating. Does that make sense? All right, so that's one example of inter-process communication. So we're talking about processes that live on the same exact computer, leveraging the operating system's API for communicating with each other. All right. So now, let me just talk about midterm for a second. So midterm is going to be Friday. What's the date we come back from break? So it would be Friday the 23rd. So Friday the 23rd. My usual exams, 10 questions. mixture of programming and short answer, no true false or multiple choice. I'll probably have some questions on there where you have to read some code. The programming questions are going to be more of, write a function in C that does something relatively simple. So don't expect horrifically hard algorithmic stuff, but more like, can you allocate some memory and do pointer math type things, those kinds of exercises. So some competency in C. I might have a couple of questions on there where I give you some C code and ask you to tell me what does this do. Those might be a little bit more complex. We should all be better at reading code than we can write it, or at least for many of us, that should be the case. You should be at least as good at reading it as you are at writing it. So I might have you read some examples and say, what does this chunk of code do? We'll go through the slides at the on that Monday and go over stuff. I'll probably cut off the stuff that will be on the exam at whatever we finish on Monday. So stuff that we do on Wednesday won't be on the exam. And then my usual thing, if you do better on the final than you did in the midterm, you can replace your midterm with whatever you get in the final. Go ahead.
I was just talking about this with Brandon in the library. What kind of are there going to be a lot of questions about networking that we've discussed on the slides and stuff?
I'm not sure. As when I go through the exercise and going through the slides and saying what I think is important and what I don't, then you'll probably know then. Because I don't know. That's when I'll know, is when I go through the slides. So there might be, but I'll ask questions that are appropriate for the material this course should cover. So for instance, if I said something that was, it might have been very interesting, but it was more of a topic for a networking course, I wouldn't ask it on an exam in here. So things that are going to be in here are going to be things that are more related to what we're doing in here. Does that make some sense?
And another question, as far as reading C code, besides looking at the really simple stuff that we did in week 2, week 3, do you want us to also go back at the server stuff that we've been recently doing and being able to read that effectively?
Oh yeah, like I said, you should be able to read more complex looking C code than I would ask you to write. Okay. That isn't to say that I wouldn't ask you to, write some code on the exam that maybe creates a child process and has the parent do one thing and the child do something else. But that's 5 lines of code. You do the fork and then you say, am I the parent or am I the child? And for something like that, I would probably even give you the hint that the parent gets the process ID of the child and the child gets a process ID of 0. That's how they can tell if that they're the child or not. So I really want you to just show that you understand the difference of creating a new process, asking who am I, and then doing different things based on if you're the parent or the child. But you certainly should be able to read stuff. Even I guess it'd be fair game for me to ask you to do some reading in from a file or something like that for the programming point, but I probably even wouldn't do that. That's something, if you had some documentation sitting in front of you, you could write that. What I really am going to be testing more is just basic C competency in terms of what you can write. But what you can read, that would be very fair game for reading from a file or sockets or something like that. And I wouldn't write something purposely to trick you. I would write something that looks straightforward, and I want you to be able to tell me, what does this code do? And so look for the obvious solution of what the code does. I wouldn't try to throw you for a loop and cause you to answer wrong because I was tricking you. So something along those lines. Other questions? All right, so exam will be Friday after we come back. We'll go over possible topics on Monday. So somebody remind me at the beginning of class. I'll spend 10 minutes to go through the slides and tell you what I think is important and what's not. And then we'll start looking at shared memory and other interprocess communication stuff. We'll create a chat server, and then we're going to evolve that into a more of a multi-user game type thing where we have ability more than just to talk. We can actually interact with other players and that kind of stuff, and that's how we'll learn about interprocess communication. All right, if you're traveling, travel safe. I will see everybody on, the 19th? Monday the 19th? Is that when we come back? Yeah, a week from Monday.